And we have with us today Steve Connor, who is the Vice President of Sales for Cloudistics. Steve, are you here?
I am, Scott. How are you doing?
I'm doing great. How about you?
I am fabulous. Thanks for asking.
And I'm going to let you take over from here.
Excellent. Excellent. All right. Well, I appreciate the time, everybody. So once again, my name is Steve Connor, and I am from Cloudistics. And we're going to cover a little different couple of topics around Hyperconverged. As I get into this, our platform that we're going to be providing a view of is a little different than traditional Converged. And having the pure conversation go before us was phenomenal. It kind of sets the stage. So to set the conversation in motion, what we're putting on the market today is basically an entire platform. So we talked about that in the last session. And what it does is it provides a platform that's hardware and software included, and we'll talk about all the pieces that are there. And it gives you the incremental scale that we've seen with those converged platforms, like the Pure Stack that we just had, and some of the control that you would expect from these hyperconverged footprints. And it gives you an experience that a lot of customers are expecting to see with the cloud. So, a lot of people are expecting ease of use, abstraction of hardware, abstraction of administration in Amazon, Azure, and Google. And that's what we're proposing that our platform will do. So over the next 25 minutes, I'll walk you through some of the things we've seen in the hyperconverged world, and then also show you how this works in our platform. So to set the stage, I've spent the last 3 years in hyperconverged space. So I wouldn't say I'm an expert, but I've been around it for a while. And when we look at that converged footprint that we're talking about, it's a great set of infrastructure that does definitely meet a lot of use cases, right? But as we've talked about it over the last hour or so, there's a lot of different pieces, right? And if you get them from different vendors or you get them particularly configured from somebody else, you may have a lot of different control planes that you have to manage yourself. And ultimately, those platforms are specifically designed to meet, I would say, kind of a workload-independent footprint. So those applications at the top of the stack are second-class citizens. So when we look at it from a converged standpoint, they do meet the incremental scale point, but not necessarily the easiest things in the world to manage. And if you've ever deployed one of those big guys, they can take literally months to stand up. Now, on the hyperconverged side of the house, when we did hyperconverged, we talked about in the last session, there's still the north-south switching piece that has to be in there. But what hyperconverged has done a great job of is taking that middle component, all the fiber channel switching, all the server and storage components, and merge them into a single footprint. And that's dramatically decreased the overall complexity of this particular type of infrastructure. Still have a couple of things around the hypervisor that you have to deal with. And still, even when I was working in the last engagement that I had, you're still looking at it more from an infrastructure focus. And those applications, although we did pay attention to workloads, are still really treated as second-class citizens. We were designed to more the infrastructure than anything else. We were eliminating the sand. So these guys are great architectures, and as we travel towards hyperconverged, there's a couple of net side effects that we've seen as we've built these things out over the last 3 to 5 years. So one of the things that I saw when I was working in this space was this idea that I call resource drift. And what that is basically when any particular use case that you have, because you're working with a node that has combined resources of compute, memory, and storage, you're going to have a resource that's going to lock in. One of the resources is getting constrained. So we use a traditional use case like VDI. It's very RAM intensive. And it does have some CPU and storage constraints along with it, but it's generally a very small footprint. As you add more nodes to address the RAM footprint, you're going to see resources get stranded. So for the second node, not that big a deal, but as you add nodes 3, 4, 5, 6, 10, 20, you start to see this drift happening. And I worked with a few service providers, and in those environments, they would end up with literally hundreds of cores locked and hundreds of terabytes locked because of the one constraining resource. So resource drift is a real issue, and it's something that we have to pay attention to with this new paradigm. And it's something that ultimately, is I don't think it's something that can be addressed effectively in hyperconverged. And I'll talk about how we address that a little bit later. When we look at the stacking of file systems, when we look at how things are done in hyperconverged systems, you've obviously got a local file system with any VM, and none of us can get around that. You're going to have a guest operating system, and it's going to have a file system. But as you travel further down in the stack, you're going to have a hypervisor that's going to have a file system as well, right? So you're going to have potentially a VMware applying a hypervisor, Hyper-V applying a hypervisor file system, and that's going to stack another layer of file systems into the overall I/O path. And then lastly, depending on what you've got underneath, and most of the hyperconverged footprints do this, you're going to have a distributed file system that's going to add another layer of file systems into the footprint. And what that does is it allows or provides additional layers of complexity that's ultimately going to add latency to the environment. So when we look at this, I gave an analogy to somebody the other day. It's kind of like, I'm speaking to you in English, but, we both speak English, but I have to have a French and Spanish interpreter between us, and it just slows the process down. So with this particular type of environment, and specifically in hyperconverged, you're going to see this file system stacking cause latency when you're going from virtual machine down to storage. So that's something that's just the natural side effect of stacking file systems. So that's something else that we've seen over time as these hyperconverged systems have become more mature. Another thing that is a thing that it's just a side effect of the way things are built is span of control. So in the last session we talked about networking. So in this environment, some of the hyperconverged footprints do have control of east-west traffic, but north-south is still not in the control. They don't have a purview of what's going on above them, and they don't have the ability to control that northwest-south traffic. So you lose some ability to have a tenant-level conversation at north-south. And then depending on the solution, even in the east-west scenario, at the storage level, because I'm spreading that out in a distributed fashion, it gives me the inability to actually block those things off from a tenanting standpoint. So in the converged world, where I may have had some level of ability to do tenants, as I move to hyperconverged, because I don't control switching or networking above me, may be controlling networking in the middle, one east-west, and have a distributed file system, I lose that capability to do some level of multi-tenancy inside of these hyperconverged footprints. Now, you can get away with doing, one customer, one cluster in this environment, but that's, in most instances, that's not true multi-tenancy. So this is something else that we've seen as we move from converged to hyperconverged. It's a side effect that we didn't expect as we were building out these systems. So those three things for me, having moved from converged through hyperconverged, are things that, ultimately I would want to correct as I go into building what I would think would be the ideal platform for either a hyperconverged or composable platform. So when we look at, how we play and where we do things in this type of environment, we said in the very beginning, we do things very cloud-like. So I'm moving into the Cloudistics footprint. So when we look at the cloud, we've got to address what they do well and what they don't do well. So, when we look at Amazon and Azure, assuming that they still have unlimited scale, and we've seen some things in the press that may argue otherwise, a lot of customers go in there and say, I'm going to go into the cloud because I know it's always going to have what I need when I need it on the day that I'm going to stand things up. So that's one of the big things that we look there. We talked about it earlier in a couple of sessions, time to market, right? You shadow IT, I think Scott talked about this earlier, stands up because they need to do things quickly, and your IT organizations may or may not be able to react fast enough if they're living in that converged world or even in the hyperconverged world. Ease of management is another thing that people move to the cloud for. Low cost of entry is another one, and then utility models are big. A lot of people move there because you can pay with it with your credit card, or ultimately it's consuming OpEx-oriented dollars, which makes things a little easier on a lot of the smaller businesses. One of the things that you get from a con standpoint, and we've all seen this, and anybody who's done Amazon-related activities or Azure-related activities, is lock-in. When you go to the cloud, you're there. Not only is it hard to get out, but you're never going to have the opportunity to truly know whether your data is being erased when you leave. We talked about application flexibility, and I mentioned that in the beginning of the conversation. With those cloud providers, you have to make your applications fit system sizes, not the other way around. So when you're going into those environments, if your application doesn't quite fit, you got to kind of shoehorn in, and that's not necessarily the best thing for especially large data footprints. From a visibility and control standpoint, I always use the analogies of these guys as being the public swimming pool. So the pool is really well structured, and it's clean and everything like that. But you don't know what your friends are doing around you. So control and security are left up to you, but not really left up to you. So that presents a little bit of a problem. Bandwidth and latency for bigger applications, especially if you're doing things like Splunk or VDI, become a little bit of a problem. And you have to think about that out of the gates when you're doing these deployments. And then lastly, if anybody's ever built or deployed things in Amazon and then left them up for 24/7, you know that it's easy to get in, but it's not necessarily easy to stay in from a cost standpoint. So that it's not necessarily the cheapest thing to maintain over time. When we look at the integrated systems play, the people that, when Gartner lumps the hyperconverged and the converged players into the single market, you have, on the bigger side, the converged side, you've got operational complexity. These things are jigsaw puzzles in some instances, and you have to put them together. That also means that you have multiple vendors to play with when you're doing support-related activities. So they're complex and sometimes pretty slow to implement. On the hyperconverged side, we talked about that drift, so that's a real issue that is a side effect of hyperconverged. And because of that, you get these inefficient provisioning scenarios where you get either resource locks, or because you're looking at node-based level solutions, you may not have the ability to actually add what you need when you need to. And then if you've ever priced some of these things out, depending on the vendor, they're not necessarily the most cost-effective. From a platforming standpoint, and what we're calling Act 3, the term that's kind of being tossed out in the industry right now is composable platforms. And when you look at that, the key things that Gartner wants to see and a lot of the industry analysts are looking to see is it needs to be simple. It absolutely has to be as easy as the cloud. You need to have the ability to focus on applications. So applications absolutely need to be first-class citizens. You need to have the ability to do true multi-tenancy, and I'll cover tenancy in gory detail in a few minutes. It has to be performant, so it's got to be able to function at the speeds of the traditional converged footprint that we were used to back in the early 2000 timeframes. Incremental scale is an absolute must, and the bottom one we've added to this particular equation, which is cloud economics, which I'll cover in a few slides. So that's what we're seeing as kind of the Act 3 of infrastructure. And if you read the latest Gartner report that talks about the state of hyperconvergence, they saw converged infrastructure being kind of the act from 2005 to 2015, hyperconverged being the act from 2010 to 2020, and now we're in composable, which is taking us from 2015 through 2025. So that's an interesting article if you ever get the opportunity to read it. When we look at taking that footprint that we just talked about and moving into this platform that we call composable, the only way to truly do that is to take over the entire stack. So when we looked at this and we built our platform includes networking, storage, and compute. So you're getting all three attributes of this stack. So single interface, single footprint, all built into one. So it truly is cloud on-prem. We've also said in order to do some of the advanced networking things that we need to do and storage management things that we need to do, you've got to tightly integrate the hypervisor into this platform in order to make all that magic happen, especially for tenancy. So in this scenario, we've integrated the hypervisor into the platform, and I'll walk through how that works on the next slide. But this gives us the ability to have that tightly integrated networking control that gives us the ability to do those advanced features. And then lastly, we take and pay attention to applications. So in our cloud portal, you have the ability to take applications from our marketplace and deploy them through single-click instancing. So we've taken the time with our TAP partners, so Citrix, any who do business with support, Works, Cloudera, Citrix, and so forth, and we've orchestrated them in our environment such as you can go into this marketplace, download a template, and simply say, I want to deploy Splunk. With that Splunk template, you can then deploy the appropriate attributes of the Splunk instances that need to go in the environment, and then once it's set up and ready to run, all you need to do is apply Splunk volume licensing, and you're ready to rock and roll. So what we see is by focusing on the application first and then tuning it in such a way that it fits the actual platform, it gives our application owners a much more rich feel when they get in. And it's very much more like an Amazon experience than a traditional infrastructure experience. When we look at the platform itself, and this is, I'll spend a little bit of time on this slide. When we look at the platform itself, everybody asks us, is it hardware and software? So I'm going to say today it is hardware and software, and it's included as a platform. We are making strides to take this to a software-oriented model only, but today when you buy a Cloudistics platform, it is hardware and software. As you can see here, it includes switches, it includes servers, we call basically hosts, and it includes a storage tier that is based on all-flash storage. So when you get this platform, it 6U, and basically everything that you need to basically set up that cloud on-premise. Everything in this environment has been completely paved. So if you're used to seeing this type of hardware, you're probably recognizing the vendor. So we do work with a major vendor to help us with the ability to support this around the globe. But in this environment, we pave everything with our own operating systems to make sure that we have direct affinity on each one of these devices and complete control of everything that's on these devices. So even though it may look like potentially a Dell platform, when you plug it in, it has no idea that it is made by or produced by Dell. When we go away from the hardware, and we don't generally talk about hardware much after we get through that first conversation, when you get into the platform itself, it is basically viewed as a pool of federated resources. So you have a pool of storage resources, you have a pool of computing resources, and you have a pool of memory resources. And those resources can be divvied up in different formats, and I'll talk about that in just a couple of seconds. But what that does is when a person comes in to do a deployment of a machine or an application through that template footprint that we have, you're basically saying, I want to deploy this. Just like in Amazon, you don't ask what machine it's on or what cluster it's going to be on, or any of that information that you would traditionally have in a VMware or Hyper-V footprint. You basically just say deploy machine. Under the covers, we make all the decisions for you, so you can know that it's going to be in an environment or a section of the footprint that's going to have all the appropriate resources that you've asked for, and we continuously rebalance that over time. You get through this through a centralized management portal. So this portal, for most of our commercial clients, is actually offered in the cloud. So we've taken the time to actually turn this into a container, and it lives in Amazon. So we've taken the time to make sure that anybody, anywhere can get access to this. Now, for some of our more security-conscious customers, people in finance or healthcare or, for our federal government clients, that's not necessarily an answer. So because it's a containerized footprint, we can actually move that on-premise and give them the ability to have basically their own version of this cloud portal on-prem. Same feature sets, same functions, it's just not hosted in the public cloud. We've also, as part of that approach with that container, fully containerized our platform. So we actually have the ability to support native Docker containers and have the ability to support persistent storage for those containers, such that whenever you take a container in or out of our system, there is no any type of manipulation of that container. It will move natively from our platform to Amazon, to Azure, or any other place that supports native Docker containers. So that centralized management platform was a driver for us to get into Docker. When we talk about independent scaling, if you remember back to my hardware picture, in order to be composable, I need to break away from the node. So the idea of the node doesn't live in our world. We have a storage block, much like the converged architectures. We have a server block, much like the converged architectures, and then we have networking. Where we get this all glued together is through the software that we've written at both the network layer and into the integration of the hypervisor. So in that world, we've basically said we're going to link all these things together. So in networking world, in this platform, there is no layer 2 networking. We basically fused all that away, and you can do everything that you need to do just through regular layer 3 networking. So if you're used to doing VNets and VMware, you're ready to rock and roll. But by doing that, we've actually introduced the idea that every component in our environment is an active participant in that network. So that gives us full tenancy capabilities. And we'll touch on that in just a couple more minutes. That also, because we've done those separations and linked everybody together with software, gives us the ability to have that independent scale. So if you need to add more storage, just like the guys that in the last session, you add storage, and it's automatically added into the cluster, and it just becomes part of the resources. As you need to add servers, same deal. You add them in, and it's added to the platform, and networking switches are the same way. So what we've done there is taken those benefits associated with independent scale with converged, taken the software attributes that you've seen with Hyperconverged, and given people back that control of incremental resource footprints inside of the platform, which eliminates that resource drift that I talked about before. Now, we talked about the idea of the file system stacking as well. In our world, because of the way we've broken this out and because we've integrated those controls into the hypervisor that we support, we also give every virtual machine direct access to block storage. So in our world, the only file system that lives is the guest file system. To the virtual machine, it appears like it's getting a vDisk, but under the covers, it's actually getting a block device that's being presented to it. And what that does for us is two things. One, obviously it makes the file system stacking go away, but it also gives us really, really solid performance. So it gives us the ability to address things like Splunk, like Hadoop, and any large big data applications you really expect to see. So by doing it that way, we get massive amounts of performance. And we see things being sub-millisecond for any type of read-write mix. And in that environment, we also have the ability to address database scenarios effectively. We have one customer that we support that's in the legal field, and they actually use a product called Relativity. And that product has standalone SQL Server databases. We went into that particular use case a little threatened by what we were going to be tested against. So we were doing a bare metal SQL Server against an under-provisioned by 1/4. So we were 1/4 of the resources, virtual machine inside of our platform. And when all the testing was done, we went to review the results, and we were surprised, positively were surprised, because our little virtual machine outpaced that physical machine by 8 times. So this particular service provider basically said, look, if we can get this type of performance on this type of SQL Server, which has been our underpinning problem of our entire service, we're in. So that construct gives us the ability to address performance at speed. And then the last thing that we address in this environment that's important and dovetails into that networking line of control that we talked about earlier, is tenancy. So because we have everything in our environment running as a participating router in that environment, we can have full tenancy, both physical separation and logical separation within those physical boundaries, and can guarantee that those boundaries will be maintained. And that's because we have complete control of north-south traffic from the switch port down to the block of storage, and complete east-west control between the hypervisors. And when the hypervisors are making a routing decision, and it's an east-west decision, they make the decision and do the routing themselves. And in that environment, we also have distributed firewall rule sets that give us the control of those east-west footprints, and that gives us the ability to make sure that every single server in that segment is partitioned and kept separate. So with that, leaving our converged footprint, going into Hyperconverged, we lost some of those capabilities because of the span of control issues and the spread file system. By coming into this composable platform, we've now brought that back through the combination of independent resources and also by taking complete control of the networking stack. So that gives you a lot of flexibility that we've kind of lost as we've gone from converged to hyperconverged. When we look at simplicity, so we talked about having the ability to be super simple in order to be cloud-like. We've basically said that everything that we need to do has to be managed from a single pane of glass. Now, under the covers, we're running basically KVM, Red Hat's version of KVM. And if anybody's ever worked with that, it's a little challenging to work with sometimes. By integrating it into this interface, we tell our customers, you should never, ever have to touch the command line of a switch, of KVM, or storage ever. So we take this complexity, which is a FlexPod. If you've ever done FlexPod, you should recognize this. It's a lot of the interfaces you should see, and this would be traditional converged infrastructure interfaces that you would expect to see, and turn it into this singular interface. So here you have complete control of all your hardware assets down to the iDRAC level. So we can actually get in and do hardware level actions if you need to. And you also have complete control of all your virtual assets, all your federated resource pools, all of your tenant zones, both logical and physical, and you have complete access to what we call our marketplace. And this marketplace has been designed to be the iPhone of our platform, and it gives you that ability to download templates from the cloud portal bring them into your system, and deploy applications at will. So you can see here we've got a collection of applications, and as we expand our TAP partnerships, we'll continue to add more to those marketplaces. Now, our platform is fully API available, so if you want to roll your own or if you want to work with us to roll application templates for you, we're glad to do that. We just will ask our partners to submit some of the requests, and we'll work to identify those software packages and roll them up and help orchestrate them. But orchestration is relatively simple in our footprint. We've also said that we wanted to focus in on applications, and I said that at the very beginning. So when we did the design of the platform, a lot of what's been said to date is that, Hyperconverged it does a great job at some of the general purpose workloads and starting to work up into the enterprise workloads. We took a different approach and basically said, hey, look, we need to tackle big, complex, and fast. And if we can do that, then we get, slow and simple along for the ride. So we focused our development in order to tackle things like Hadoop, things like MapR, Hortonworks, Cloudera, and Splunk, and also from the complexities of container standpoint. And we've got scenarios now where we're doing, pilots for large cable companies where we can do 20 terabytes of ingest with consistent search going on simultaneously and have 30 days of retention and 6U. And they told us that footprint would be a rack of stuff running, roughly 2.5 million in a converged footprint. So we're seeing that the way we've designed our system gives people not only the ability to manage a really simple footprint, but also dramatically shrink the overall footprint that it takes in the data center and the administrative level that it takes to actually manage that footprint. The other thing that we did, and I'll work this in and describe how we do this from a pricing standpoint. In order to be cloud-like, we needed to make sure that we had the economic scenario set up to where you could consume similarly to the cloud. So in a traditional vendor world, obviously, there's the idea of buy a box, sell a box. So just like any hyperconverged environment, we have the ability to do incremental scale. So you can start out as little as 2 host machines, 2 switches, and 3 terabytes of storage, and that's your primary cloud platform, and then scale it incrementally up from there. And as we said before, you can scale that out independently, each resource scaling on its own. So you're never going to have to worry about that drift or lock. When you go into the consumption side of the house, however, we needed to address the idea of operating control. So Amazon and Azure do everything by the month, and it's based on either on-demand instances or reserved instances. So what we've said is that we need to do the same thing. So when we do this, we offer a consumption model to all customers. It's not predicated on being a particular type of customer or partner. You can come in, and we have to work to get the hardware on site. So that's either going to come through us or potentially through Dell. But once we have the hardware on site, you have the option to consume our software based on simple resources. So you can commit to us literally nothing if you want to, and basically say, I want to pay just like Amazon on demand. And I'm going to pay on CPU hour. I'm going to pay by gigabytes per month. And we can measure those things down to the second if we need to. And what that does is it gives our customers the ability to get in and say, you know what, I really don't know what I'm going to use for this particular use case. Why don't I go on demand? And let me do that footprint until I really get a feel for it. And then I will either up my footprint from a commitment standpoint or just convert it. So when you go into this environment, after you get through that initial I don't know phase, you can commit to us on 2 axes. You can either commit on time. The longer the commitment, just like an Amazon reserved instance, the better the price you're going to get on incremental resources. And that goes up between 3 and 5 years is the longest commitment that we'll do. And you have the other axis of resources. So you can, just like back in the days of networking where you did committed information rates, you can say, I'm going to commit to 25% CPU utilization and potentially maybe 50% storage utilization. And by committing to those as your base unit for a monthly recurring price, you can buy down the cost of that unit and then any bursting unit above that, because obviously you have the full capability and breadth of the platform to grow into above that base. And what that gives our customers the ability to do is take that resource footprint and actually roll it out as an OpEx. We see this as being a large benefit to our service provider customers, the guys that have to map their resources, their costs, to their overall revenue footprint. And we also see this potentially beneficial to any business that doesn't know what their use case is going to look like. So this could be test dev. It could be a use case that's brand new greenfield. It could be any use case that has that profile. And if you have a capital expenditure issue, it gives you a big case on OpEx. So we've decided that in order to meet that cloud economics piece that I talked about earlier, we had to be able to do this. So with our platform, and covering all the things that we talked about in the very beginning, it is a complete platform that addresses those side effects that we covered in the very beginning of the conversation. Through this single interface and the application marketplace, you have the ability to manage everything: routing, switching, compute, and storage. So you never have to leave this one interface to manage everything that you would need from the cloud, very much like Amazon. Application specificity is there, so you can basically build whatever you want in this environment, and you can make the systems match. And we've done a lot of that for you in advance, so we've done a lot of tuning for the applications we support. As I discussed earlier, because we control the entire stack, east, west, north, south, you get complete tenancy, both physically and logically. Performance is sub-millisecond for any read-write transaction. Scale is done at every level of the footprint, and with our on-demand pricing, you have the ability to get those cloud economics that you would expect of Amazon. So with that, if you're looking to get into Cloudistics, you can reach out to us at sales@cloudistics.com. That will come to anyone on my team. And we have the ability for you to basically give it a low-risk test drive. So you can come into our virtual lab, feels what it likes to run an entire platform, and kick the tires. And we generally open that up for about a 24-hour period, so you can just get a feel for how the cloud platform works. So with that, Scott, I think I'm running on time or close to on time, so I'm going to stop and give it back to you for questions.
Perfect. We've got a bunch of them. We'll get it through as many as we can. The first question is, we use vSphere today. Do I have to abandon those, or can I convert them to work on Cloudistics?
Repeat it. Could you repeat that one more time, Scott? I'm sorry.
The person says they're a vSphere user today, and they want to move to Cloudistics. Do they have to abandon that, or can they convert? Basically, can they convert, or do they have to rebuild?
That is a great question. So we actually have inside the Cloud Portal capability a visual import tool. So basically, all you have to do is be able to mount your vCenter, your ESX host, and be able to see the VMDKs, and we will automatically import them into the footprint. We can also do that for Hyper-V instances as well. So you would not have to abandon or rebuild. And the cool thing with that, Scott, is because of our storage, and I'm sure somebody's going to ask me the dedupe and compression question, inside of our environment, we do everything single instance. So it's on by default. So when we process things in or build inside from our templates, we're checking for single instance capabilities. So if those virtual machines are roughly equivalent, we're going to create one instance and only one instance and then create pointers to it. So it dramatically decreases on the amount of storage you're going to use. And that's how we handle deduplication. Because we control everything, we can have that level of view inside of the storage.
The next question is, for Cloudistics, can latency be tunable for on-demand applications, for example, doing quality of service on an application basis?
So in our network, I'm going to give you two answers to that question because quality of service has a couple of different pieces. So in our network, we don't have QoS from a QoS standpoint because everything's non-blocking. So every route path that you get from point A to point B is completely non-blocking, so you get full line speed. So on the network side, because we've done it that way, you don't really have to worry about your neighbor being noisy on that particular scenario. When you get into virtual machine LAN and storage LAN, the storage ones, we don't have to worry about that either because there's iSCSI mappings directly to the virtual machine. So those LUNs that are represented as VDisks are going to be directly mapped to that. And through that non-blocking network, they get full access to that particular LUN. In the virtual machine world, where we're working at memory and compute, that's where you get into oversubscription scenarios inside of our platform. So at the migration zone, which is the physical tenant, and the virtual data center, which is the logical tenant, you have complete control over how you do oversubscription ratios. So what we do there is work with our customers to balance those subscription ratios, and you can do that for memory, storage, and compute. and make sure that we're not overrunning any of those particular footprints. You can set them up so they don't overrun as well. So is it true QoS? Like, can I rate shape to a certain amount of memory bandwidth? No, but can I do it from a standpoint of resource partitioning? Absolutely.
I hate to say it, but it's all the time we have. Thank you so much for being here today. I think this was a great presentation, educational for our audience. And if you want to learn more about Cloudistics, obviously go to their website, go to cloudistics.com for the free test drive that they talked about.